wabarakatuh. We proceed with the number average degree xn and weight average degree, which is xw. And the number average degree of polymerization and weight average degree is considered for type 1 reaction. So type 1 reaction, can we recall what is type 1 reaction? Involve the two different monomer, and each monomer possesses only one type of functional group. And the possibility of non-stoichiometric quantities in type 2 reaction is complicated. Okay, so xn equal to 1 over 1 minus p, and xw is equal to 1 plus p over 1 minus p. So we can get the MWD, which is PDI, or polydispersity index, okay, can be expressed by the equation xw divided by xn equal to 1 plus p. Can we relate the number average molecular weight? Okay, so the average molecular weight of monomer in repeat unit, which is the m naught, represented by mn equal to xn m naught. So m naught is equal to mn over xn, ataupun mn equal to m naught over 1 minus p. So m naught is actually the half of the molecular weight of repeat units. So if repeat unit contains 2 monomer, sini m naught tu adalah separuh daripada molecular weight monomer dalam repeat unit tersebut. So sometimes the question asks you to define the molecular weight and mn. Okay, for example, define mw and mn in terms of p. So you need to come out with the equation of xn, which is xn equal to n naught over n naught 1 minus p equal to 1 over 1 minus p. So you can derive from the main equation, which is xn, and you can get the mn equal to mo over 1 minus p. So from that you can derive from mw, and the last one you will get mw equal to m naught 1 plus p and 1 minus p. This one is an example of question that asked in the final exam. Express the relation between the average degree of polymerization, which is xn, with the extent of the reaction given by p, and the number average molecular weight mn, and give one implication of the mentioned relationship. First of all, you need to come out with the formula, or xn equal to dp. Xn is always equal to dp, which is 1 over 1 minus p. And then you come out with the mn equal to m naught over 1 minus p. So each equation you derive here, you can get 1 mark each. And mw, which is given by the previous equation, you can get m naught bracket 1 plus p over 1 minus p. So xw is 1 plus p over 1 minus p. You just substitute, okay, mn over m naught over, bukan substitute, apa ni yang panggil, you just switch the location of the mn, okay, algebra. This is the algebra equation, equal to 1 over 1 minus p. Hence you will get xn equal to mn over m naught. So any equation you can get 1 mark each. So I just choose any 5 equation, and if you give a good explanation on the implication of this equation, you will get 1 marks. So the implication is, you can say that xn is proportional to mn. Okay, as you can see here in the equation, xn is proportional to the mn, and it is inversely proportional to m naught. Means that if you get high xn or high degree of polymerization, you can get high conversion or P, also known as the extent of reaction, and you can get high Mn, which is number average molecular weight. Get the example of the question to relate the number average molecular weight. Okay, for example, we have a monomer of diacid and diamine to produce polyamide. As we can see that the stoichiometric balance number of mole in diacid contains 10 mole and diamine also 10 mole. And the number of each repeating units in diacid in the preparation of polyamide or the product of polyamide here, we get 114 gram over mole. And the amine, the repeating units for diamine, we get 112 gram over mole. So m naught is equal to 113. How can we get m naught equal to 113? Any idea? And refer to the previous slide. M naught is equal to average molecular weight of the monomer. So you just add on 114 with 112, okay, and divided by 2, you can get M naught, which is 113. Okay, maksudnya separuh daripada molecular weight polyamide ni. Ini adalah molecular weight polyamide yang awak dapat, 114 and 112. Tambah 2 ni kan. So nak tahu dia punya average molecular weight of the monomer, which is half of the molecular weight polymer in the repeating units, you can divide it by 2. And if the number of the repeat units, which is n equal to 10, okay, so if is the number of the repeat unit is given by 10, so you have 2 repeat units, right? So you just multiply with 2. You can get xn equal to 20. If the question asks you to calculate the number average molecular weight, so you can use the equation Mn equal to xn times m naught. And xn as calculated above, we got 20 times with the m naught, 113 gram over mole. So the Mn value is 2260 gram over mole. Okay, this one is another example. You can try polycondensation of 10 hydroxydecanoic acid produce 24,300 gram over mole average molecular weight as represented in the structure. So calculate the degree of polymerization of all molecule and the percent conversion of the reaction. With how to measure the MWD or PDI. So to determine the PDI, the equation used is MW over Mn. So define MW and Mn in terms of P. Okay, this one given by Xn. Okay, Xn always equal to 1 over 1 minus P. So from the definition of Xn, Mn equal to m naught over 1 minus P. And for MW, MW is sums of Wx and X. So we write for X unit is MW is Wx Xm naught. So I think this equation is quite confusing. And PDI is given by MW over Mn equal to 1 plus P. And this tells us that at a very high level of conversion, as P approaches to 1, the most probable PDI is MW over Mn, which is approaching 2. So I think you can use another notes or another paper so that you can write down back the equation so that you can see a clear vision of this equation. Now we proceed the next section, which is polyfunctional. Okay, what is polyfunctional? Okay, polyfunctional means that it contains a functionality more than 2. So formation of a linear polymer, we can see that it has a single linear structure or linear monomer react with a second monomer to produce a linear polymer. So if you have more than two functionality, we can produce a polyfunctional. So in this equation, we have three functionality, which is three functional group, react with two functionality, two functional group. So we can have 1, 2, 3, 4, 5, and then it will combine to produce a network polymer. So in the average functionality, the term used are FAVE of a mixture of monomers. It is the average number of functional group per monomer molecule for all types of monomer molecule, defined as the sums of Nx Fx divided by the sums of Nx. Nx is the number of molecule of monomer X with the functionality X, and the summation are over all the monomers present in the system. Okay, the total all the monomer in the system. For a system consisting of 2 mole of glycerol, okay, a glycerol, it has, kalau kita tengok structure glycerol, it has 3 OH group. So it react with 3 mole of folic acid or a diacid. So there is a total of 12 functional group per 5 monomer molecule. So we use the equation NXFX divided by NX to represent the 2 mole of glycerol times with the number of functionality. As I mentioned earlier, glycerol have 3 OH group, so 3 is represent the functionality of OH group. Plus with the folic acid, we have 3 mole of folic acid. 3 in the front equation is the number of mole of folic acid times with the F, which is the functionality of the folic acid, which is 2. You can Google to look at the structure of folic acid, and divided with the number of mole, which is number represent the front equation kat depan ni, 2 plus with 3, bukan yang number yang belakang ni, sebab number dia sama kan. So you take out the number in front of the equation, number of mole, 2 plus with 3, you can get 5, and divided 12 over 5, you got 2.4 number of average functionality in that reaction. So for a system that consists of an equimolar amount of glycerol, folic anhydride, and a monobasic acid, so if you have three reaction that consists of 3 monomer, there is a total of 6 functional group per 3 monomer molecule. So you just divided 6 over 3, you can get 2. Okay, in case it consists of equimolar amount of number of mole and also the functionality. So number of functionality is related to the characters theory of gelation. So number average functionality, such I mentioned earlier, is represented by FAB. So we use the equation N naught F naught over sums of Ni. Not N naught, it is Ni. So there is another equation to calculate the extent of reaction, which is P. We use the equation 2 N naught minus N, and N naught FAV. The above sum is the number of functional group that have reacted, and the below one is the total number of functional group present. So Xn equal to 2 over 2 minus P FAV. So which equation you can use? You must use this equation. Okay, P equal to 2 over FAV. So this one is the value of Xn for different value of extent of reaction and